Welcome to the first in a series of videos um, walking through 3061 lib. A lot of what I'll share is either in the 3061 lib README, referenced in the various additional reference within the README at the bottom, in the WPI lib docs, in the documentation for other tools that are used, such as Advantage Kit and Path Planner and things like that. But I'm hoping this series of videos is helpful for those new to 3061 lib, whether new members to Husky Robotics or other teams, and providing a bit more of the context um, as we look through the structure of 3061 lib. I do try to add in comments to provide that context, explain the why, um, but certainly more information is helpful. So the approach I'm going to take in this series of videos is to go from the top down, to start at the highest levels of 3061 lib or really any FRC project in general, and then work the way down into specifics. So to do with that, everything starts within the main class. This class isn't modified at all. So this is generated by the WPI lib tools. We don't change it at all for 3061 lib. Um, all that's really important here is that the start robot method is invoked on the robot base class. That's it. And it makes a new robot object right here, which is what we'll look at next. All that is important is that here in the main method, it makes a new robot object and then passes that along to the start robot static method of the robot base class. That's it. So nothing in here needs to change. Where things get more interesting is inside of the robot class. So we'll take a look at that next. Okay. We extend in 3061 lib. Our robot class extends logged robot because we do leverage Advantage Kit um, to a great degree. And as it mentions in the README, the Advantage Kit templates may be all that your team needs for the goals that you're trying to achieve. 3061 lib has a bunch of other stuff adjacent to that that is built on top of what's provided by the Advantage Kit templates. But certainly a lot of the code that you'll see throughout these higher level classes, at least, are is very similar to Advantage Kit templates. All right, so we're not going to worry a lot about instance variables and things. We're going to focus more on the code and explaining why we do certain things that we do. This is useful for, at least I think it is. We create an instance of the LED class at the very first thing that the robot class constructor does. And this is useful because it does this like white breath animation, and it reassures everyone, especially me, that the code is in fact loading on the robot. And so that is a feature that I first saw in the mechanical advantage code. We use Advantage Kit to log a lot of metadata about the current run of the code. So you can see all of that information here. That's always available in Advantage Scope to look at later. The traceability provided by the Git stuff especially is useful. We combine this with VS Code extension authored by Mechanical Advantage that we use at events to ensure that every time code is deployed to the robot at an event, generates an automatic commit. So therefore, everything that ever happens on the field is traceable from a code perspective. But that only is enabled when we're at events. So that's the metadata. Other things here, this next section of code right here really focuses on one of the key features of Advantage Kit, where it allows us to obviously run code on a robot like normal and log a lot of information about the robot's operation, but we can also run in simulation, which is useful. And so we handle that here. We'll talk more about simulations. We go through various classes. And perhaps most useful, we can replay from a log file um, and change code, log new values, and generate a new log file of that replay. That's extremely useful for debugging very tricky situations. So this is pretty standard boilerplate code for all of that. Your path may need to be a little bit different depending on where your USB flash drive is for logging. Let's see, we use Elastic Dashboard. We think that's fantastic. And so this starts the Elastic Dashboard server that allows us to download the layout from this server, which is fantastic. And that makes it very easy to ensure that on multiple different computers, everyone is using the same Elastic Dashboard layout file. Some other stuff that happens right away is we use local AD star AK. This is a special class for Advantage Kit to resolve a potential issue related to that. And so we set that as the pathfinder right away because that's what the path planner documentation tells us to do. We have some other specific logging things here related to commands. This is code again from the Advantage Kit template, I believe, which logs commands uniquely based on like a hash code, as well as just commands based on their names. And this can be very useful for debugging as well. We also use the on command initialize, finish, and interrupt methods. For logging those commands as well. All right, that's how we connect it all together. When we are running in simulation, we default to the Blue Alliance. It just saves. We do most of our testing in the Blue Alliance. It is important to test in the Red Alliance as well, but we do most of our testing in the Blue Alliance, and this saves us having to change that configuration every time we run in simulation. So, what else we got here? Path Planner specific things. We plug into Planner's logging features here to log the current pose, the target pose, and the active path for any Path Planner path. And that can be helpful for debugging and tuning as well. We have a variety of timers here related to CAN and the canivore and being disabled. So we restart all of those as the robot is being constructed. Some other interesting things we are doing. This code here is taken from Mechanical Advantages code in 2025, I believe. We have lots of features within 3061 lib that help us do performance metrics and profiling, and the warnings that you get to the console that you have overrun your loop timing are not particularly helpful for us and make that performance issue even worse as it logs those messages. So here is a somewhat hacky way to change that timeout for that message. So it is 200 milliseconds, 0.2 seconds instead of 20 milliseconds for that warning. And so we only do that when we're not in tuning mode. Because when we're in tuning mode, we're testing a bunch of things, it's okay to have those extra messages and stuff, but this helps a little bit in terms of performance. To be clear, we're not ignoring those warnings, we're aware of them through other means. One of the important things that the robot class needs to do is it needs to make a new robot container. That's done in all the standard WPI lib project templates. We also create a new CAN bus object here to get a reference to our canivore. And we'll see where we use that in a moment for doing some monitoring. This is very useful. Some teams I've helped have benefited from adding this line of code here. We do the warm-up command. We schedule that for pathfinding. That's part of Path Planner. That causes a lot of Path Planner related classes to load. At this point in time, that is when the robot is being constructed. which is fine. Like there's lots of loading stuff going on here. It takes a while for all this code to load. We'd rather take the performance at then and not, for example, at the start of auto, where you can have a big delay at the start of auto, relatively big delay at the start of auto, waiting for those classes to load. So we do that as recommended by the Path Planner documentation. Here's something to be careful about. This became popular in 2025, I think. It caused certainly some issues for various teams. We had some little issues until we developed our understanding and did more testing to better understand the implications of what we were doing. But it's all about changing your thread priority as you go. Um, we do, as you see, if we're not in tuning mode, like, at a competition running for real, we do change the thread priority. We change it to a real-time thread with a priority of 10, and we leave it there. We have found that changing the thread priority actually is a significant performance hit, so we don't want to change it as code is running. We just want to change it up front once. This we do make very sure that our loop times are reasonable, right around 20 milliseconds, usually much less. And that way we're not going to starve other threads. That could result in all sorts of problems. For example, it looks like your CAN bus isn't working because you're starving the CTRE's Phoenix thread from getting updates from the CAN bus, things like that. So be real careful with this. If you have long loop times and you have code like this, things will not work. All right, other highlights. So that's just the constructor. That's all the stuff to get stuff up and running. So what we're going to shift now into is the robot periodic method. This is the method that runs every 20 milliseconds. We use 20 millisecond loop time, which is the default loop time. And these are the things that happen through every loop as the robot is running. This code runs whether the robot is enabled or disabled, so all the time. Couple things we do up front. So log tracer, we'll talk a little bit more about later, but log tracer is a class from Mechanical Advantage, which we leverage to do profiling throughout our subsystems and different parts of our robot code. So we start off resetting that at the start of robot periodic. Another performance optimization we do is that we take advantage of Phoenix 6's ability to refresh all signals and synchronize them at the same time on the CAN bus. We do that for all of the signals for all of our subsystems. And so we'll look more at the Phoenix 6 util later, but this call here basically refreshes all of the signals for all of the subsystems at the start of robot periodic. And then we will not need to refresh anything anywhere else in our code. And then we do record, well, how long did it take for us to do that? So we can look later and see the performance of that. This section right here is very standard. As part of the WPI lib project template. This is where you basically tell the command scheduler to run. And there's some good documentation in WPI lib docs explaining how that command scheduler works and figures out if there are new commands to schedule and execute those commands that are already scheduled and see if commands are finished or interrupted and all of those types of things. We also log how long it takes to run all of the scheduled commands. What else have we got going on here? We check the CAN status here. Um, this is also useful. Um, I don't remember what this is. Let's check. Oh, yeah, sorry. So here, we want to keep track of, are we dropping any messages, any logs using Advantage Kit? And so if we do, we want to generate an alert, which will be displayed on our dashboard if that is the case. And so that's where we could take care of that right here. All right, CAN status stuff. So we get the CAN status from the Robo Rios CAN bus, and we log the statistics from that. Um, We also have some timing here to see if we have errors. Um, and if we do, we want to generate an alert for that as well. Um, we do similar thing with the carnivore. We check, we get all of its statistics. We log all of that. We then check if we have any errors for any sustained period of time. And if so, we generate an alert for that as well. Um, we use the NT client logger class, again from Mechanical Advantage 6328. So we log all of the clients, the network table clients connected to this server. So we're aware of what's going on there. Other things we do is we keep track of a disabled timer. Um, and we use that to see if the battery voltage is low. So this is only going to be checked, and if so, we generate an alert for that as well. Um, we only check this when we're disabled in the sense. The battery will certainly dip throughout while the robot is performing operations. We want to look for this alert when the robot is disabled. So use the disabled timer to help us with that. Um, and make sure we've been disabled for a short period of time, 1.5 seconds. All right. As you saw when we looked at the constructor for the robot class, there's a lot that goes on there. And so therefore, we generate an alert for the first 45 seconds. Again, this is another mechanical advantage technique, so that our driver and operator can see that, hey, we're still there's still the just in time compiling goes on. There's still all this extra garbage collection going on. Give the robot some time to get things up and running here before we take off and expect high performance loop times. Um, the garbage collection hit can be significant in your loop times. Um, some other stuff again from the mechanical advantage. I think it's in the Advantage kit templates. I'm not sure, but certainly in their code. Um, we keep track of the autos and log and print out how long it took for them to finish, to see if like when did it finish or was it canceled? For example, like the 15-second autonomous period has ended, and then we're beginning teleop time. So we keep track of that as well. And then we call the periodic method in robot container. That's because we have some general robot stuff we want to do in every loop, whether we're enabled or not. And so this allows us a place to do that. And again, we use log tracer here to record, well, how much time did we spend in robot periodic in total? All right, let's look at some other methods here. um, Disabled periodic. This method, unlike robot periodic, will only run when the robot is disabled. So there's some things that usually have greater performance implications that we only want to do and check when the robot is disabled. And we'll look at each of these in more detail later, but we, for example, check the operator interface. What I mean by that is like the joysticks, the controller, the button panel. We check and see if it's changed. So as devices are plugged in and plugged out, and as they're seen in USB, the collection of joysticks and controllers and button panels can change over time. And when that does, we need to be aware of that fact and make sure our button mappings are done correctly. One of the features of 3061 lib is allowing a variety of collections of joysticks, controllers, and whatnot to be used more or less interchangeably, so that you can have your official operator console with joysticks, controllers, button panels, whatever, and you can still control your robot with maybe just a controller for testing purposes and have all of that just work seamlessly. We also check our alliance color here. We want to know if we're on the red or blue alliance. Um, there's threads about this in Chief Delphi. That is harder than it might appear. And so we try to follow best practices for making sure we know which alliance we're on. That affects things like which way you drive. So it's really important to get that right. Um, Also here in disabled periodic, is where this is something we've added in 2025. This is just to help the drive team make sure that they've selected an auto before the match starts. So by default, our auto selector goes to do nothing, which is probably not what we want. And so this checks to see that if do nothing is still the selected auto command in the dashboard, it displays the LEDs in with the no auto selected color. You can look up what that is. I'm sure it's dramatic. To let them know and generates an alert to let them know, like, hey, make sure you select an auto before this match starts. So um, important. All right, a couple other methods in here. Autonomous init. This method is called at the beginning of the autonomous period. Again, we don't want to do anything that takes up too much time in here. We do need to check the alliance color. Um, the alliance color is not guaranteed to be correct by the field management system until the start of autonomous. We have to do one more check there and see if like there's been a change. Um, we keep track of when the autonomous period started, and that's so we can do the logging later. The rest of this is pretty normal. This comes from the WPI lib project. We figure out what is the command selected in the auto chooser. Our code is a little bit different. We have an autonomous commands factory that has that responsibility instead of putting it here. And then assuming a command has been selected, it is scheduled and off we go. There's some other robot container specific information we want to do an autonomous start since we have a method here to do that. Very similarly, here's the teleop init method. This method is called at the start of the teleop period. This is all pretty standard from the WPI lib project. If there was an autonomous command, we make sure to cancel it because we don't want the autonomous thing running anymore. And then again, there's some robot container specific stuff we want to do at the start of the teleop period. And so we call that method as well. We don't use the test stuff at all. So this is just left here as it's part of the WPI lib project. All right, so in the next video, we're going to jump into robot container, which is a fairly substantial class, and talk through the various features within that class.